Ever wondered how scientists predict solar storms that could knock out satellites or disrupt power grids? What if I told you a new dataset is revolutionizing how we tackle these space weather mysteries? Meet SuryaBench, a groundbreaking tool blending solar physics and machine learning to unlock the sun's secrets. Let's dive in. The sun isn't just a glowing ball in the sky, it's a dynamic powerhouse. Its eruptions, like solar flares and coronal mass ejections, can ripple across the solar system, affecting everything from GPS signals to airline routes. But predicting these events, that's a huge challenge. Enter NASA's Solar Dynamics Observatory, SDO, a satellite that's been capturing 1.5 terabytes of data every day since 2010. But raw data, it's like a messy kitchen, hard to work with unless you clean it up. Here's the catch. SDO's data is massive, high resolution, and full of valuable clues, but it's not machine learning ready. Think of it as a library with thousands of books, but no index. Scientists needed a way to standardize this data, correct for spacecraft wobbles, and make it usable for AI models. That's where SuryaBench comes in. SuryaBench is like a curated, supercharged version of SDO's data. It preserves the original 4096 x 4096 resolution, so you're seeing every detail of the sun's surface and atmosphere. Plus, it's been pre-processed to fix things like camera tilt, exposure times, and even aging sensors. The result? A dataset so clean, it's a goldmine for AI. But what can you do with it? SuryaBench isn't just a data dump, it's a toolkit for 6 critical space weather challenges. 1. Solar flare prediction, catching eruptions before they hit Earth. 2. Active region tracking, mapping magnetic zones that fuel storms. 3. Coronal field modeling, reconstructing the sun's magnetic skeleton. 4. Solar wind forecasting, predicting particle flows that buffet our planet. 5. EUV irradiance analysis, understanding how sunlight heats our atmosphere. 6. Coronal hole detection, spotting regions where solar winds blast out. Why does this matter? Imagine an AI model trained on SuryaBench, predicting a solar storm days in advance. That could give power companies time to shield grids or satellites to power down. It's not just science, it's a lifeline for our tech-dependent world. Now here's where things get even more exciting. SuryaBench isn't just a dataset, it's a playground for cutting-edge machine learning. Researchers are using models like UNet and its advanced cousin, Attention UNet, to decode the sun's chaotic behavior. Think of them as supercharged tools that can spot patterns across different scales, like noticing both the big picture and tiny details in a painting. Unlike older networks, these models understand how different parts of the sun's data connect spatially, making them far better at predicting complex, high-dimensional data. But here's where it gets really cool. Scientists pitted these models against another approach, a SpatioTemporal attention network versus a SpatioTemporal RayNet. The attention version. It's like giving the AI a 2-step dance card. First, it focuses on individual spots on the sun's surface over time, temporal attention, then zooms out to see how all those spots interact, spatial attention. The RayNet, meanwhile, relies on 3D convolutions. Think of it as a more traditional step-by-step scan. And the results? Models with attention mechanisms, like the Attention UNet or deeper RayNets, learned faster and made fewer errors. Imagine training a dog to fetch. The smarter the dog or model, the quicker it grasps the game. These networks didn't just guess. They understood the sun's rhythms, leading to more reliable forecasts. Why does this matter? Better solar forecasts mean we can protect satellites, power grids, and even astronauts from space weather storms. It's a prime example of how AI isn't just for self-driving cars or voice assistants. It's solving some of the universe's toughest puzzles. So next time you hear about solar flares or auroras, remember, behind the scenes, AI is working overtime to keep us one step ahead. Stay curious, and let's keep exploring the future of AI together.